in this tutorial I'll be explaining the maximum rectangle area in a histogram algorithm, I guess. So this algorithm basically finds the maximum rectangle area in a histogram. But yeah, all right, so let's get into it. So let's say we have a bar of bar number 1 is height 1, bar number 2 is height 2, 3 is 2, and 4 is 1. Right? So we want to find the largest rectangle area in this histogram. So well, the answer would be having the height of the thing be this height and then the width be this height. So with the area of 4, right? So and then for simplicity, assume that each bar has a width of 1. Okay? So this rectangle with a area of 4, or this rectangle with also 4 as the area, right? Because 1 times 1 plus 1 plus 1 plus 1, which is obviously 4. Okay, so how do we find this? All right, so first what we want to do is we want to traverse over each edge, each bar, sorry. So and each time we traverse over it, we want to find the maximum area, I guess find the area of maximum area of the rectangle, with the smallest bar being the bar we're considering currently. So basically, so here, let's start with bar number 1. So 1, right? The height is 1, and we wanna find the leftmost bar on the right side of bar 1 that's shorter than bar 1. So 1, right? So we want to find a bar that's shorter than this on the right side. So let's say we add a bar here with the area of 0.5, right? 0.5. So on to the right side, 2 is greater than 1, 2 is also great. 2 is greater than 1, 1 is greater than or equal to 1. It's equal, so we still go on. But 0.5 is smaller than 1. So we don't consider this, and we stop right here. Okay, we stop with on bar 4, right? And then let's say we do the same thing to the left side. So let's say this bar is also 0.5. So well, it's 0.5, so we just 0.5 is smaller than 1, so we just stop there. So on each side, on each bar, we want to find the rightmost or the leftmost bar on the right side of the bar we're considering that's shorter than the bar we're considering. All right? Okay. So here, we do that to number 2 as well. So to the right side, 2 is greater than or equal to 2, so we continue. 1 is smaller than 2, so we stop right there. So to the right side, we consider this bar, and we go to the left now. So 1 is smaller than 2, so we just stop right here. So the area we get for this bar is we considered this bar and this bar with the area of 4. Right, and then in the previous one, the area was also 4, right? Because we considered this bar, this bar, this bar, this bar, and we stopped at these 2 bars. Right? So okay, so we do that for every other one. We get area 4 for this one as well, and area 4 for this one. And that's basically like the little neat algorithm that works to find the maximal rectangle area in a histogram. So how would we actually code this, right? So we want to maintain a stack. So it's basically if anyone's familiar with stack, you would probably be familiar with finding the rightmost value that's lesser than I guess that's smaller than the value we're considering. So like, let's have 1, 0, 3, 2, and like 5, right? 1, there's no smaller value that's on to the left of it, so we get rid of that. 0, we also don't have a value less than that. So 3, 0 is the rightmost value that's left to the to this value. So 3, that's smaller than it, so we get rid of 0. 2, same thing. 0, 5, 2. Right? So that's like basically we're doing this problem, but with bars, right? And then we do it to the right. We do it to the left side and the right side. So if you don't know how to do that problem, you can just go over to usico.guide. That's where I learned it. Go to gold, go to stacks, and then here we go, near a smaller element. So this has a good reading on it. I'll put the link below in the description. But yeah, we're basically doing that problem, but with bar. And then here, now that we know how to do this, let's get rid of this and let's work on an example problem. So here, CSES Problemset, maximum building number 1. You're given a map of forest where some squares are empty and some squares have trees. What is the maximum area of the rectangle building that can be placed in the forest so that no trees must be cut down? Okay, so here, it's not that obvious. Well, yeah, it's not that obvious on how we're gonna apply the the largest rectangle in a histogram thing. But so basically what we want to do here is we want to consider, so we want to traverse through each either column or row, and then make a bar out of it. So here, let's draw it out. Okay, I finished drawing the thing, right? All right, so basically, so as I said, we want to consider each column or row. So, but I'll consider the column. So here, let's consider this column now, right? The first column. So we want to build I guess like actually here, for simplicity, let's consider the third column. So we want to consider histograms as a bar that's going this way, and a bar that works. So here, size this with a size of 1, 3, 1, 3, 3, right? So the reason why we stopped here is that there's a tree, so we can't include that tree in the bar. So yeah, that's why we stopped there. So we have bars with 3, 1, 3, 3, right? And then now we can just do the algorithm right here. And then we can also and to get the actual answer for our thing, we consider this column, right? We have a bar of 4, 4, whoops, 4, 4, 4, right? 4, 4, 4, and then 0, right? And then obviously by looking at this, the maximum area would be this rectangle, right? So 4 by 3, which is equal to 12, right? And then and that's also the answer to this, 12. And basically we just want to do the bar histogram rectangle algorithm onto this by just traversing all over the column or the edge and then getting a bar out of it. So making a bar out of those indexes, right? And then the actual implementation would be right here. I'm not gonna go over the code right now, but So I'll just put it in the description with some comments on it, like I explain what the code does. But actually, here I'll just explain it right now. So basically, yeah, this is the code to this problem right here, maximum building. So here, this is, I just got the inputs as an array of strings. I'm gonna store the histogram right here. So board ij equals, well, here. So histogram ij is basically here. So I is the row, right? And then j is the column. So basically histogram 0, 2. This is the this stores the height of the histogram on 0, 2, which is this. So 1, 2 would be this. Actually, no, this, right? And so on. So that basically stores that. And then so here we're implementing the, okay, yeah. So we declare the answer. Here we're traversing over the column. And then here we're just doing the algorithm, the stack algorithm, where we find the rightmost value, or the leftmost value on the right side, that's on the right side of the thing we're considering, that's smaller than the bar. And then I did that to the right side and the left side, and the answer would just be well, max of ri and li plus 1 times, I guess, the area of the histogram, right? And then we just print out the answer. And yeah, this is this is a good example on how we use the algorithm to solve for this problem. And yeah, that's it. Bye.